Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of PG Mustard. This is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, let's talk about upgrades.
Yep, specifically...
Your choice, as usual, very boring topic, which I don't like, but we all need to do it. I like to be always running the freshest version, including minor version of Postgres. But no, we don't have, like CI/CD with automatic deployments to all Postgres installations, unfortunately, right?
Well, that's one of the reasons I really like this topic, though. I think it's something that a lot of people want to be often on the latest version, or there'd be benefits for doing that, but there's enough downsides, or there's enough friction at the moment. It's not always easy for people to be on the latest versions, and there can be quite a lot of work involved. So I wanted to discuss that a little bit, things that we can do to minimize that, or give people tips on things to look out for. But yeah, I was actually surprised how many people. I did a quick poll before the episode on social media, and I think about a third of people are like you. They like to upgrade it every year, which is, well, I guess that doesn't necessarily mean they're on the latest version.
Well, I like to upgrade at least once per quarter if we talk about minor upgrades. Right. And
yes, so should we go to that first, actually, in terms of what the differences are?
Yeah, let's discuss. So minor upgrades is like security or bug fix upgrades. They don't change anything in terms of functionality most often. Sometimes some features are. And major upgrades are every year we have big major Postgres version, new one, with a lot of new things, usually very good ones.
So yes, in terms of it's not like some projects, right? So some projects you get kind of semantic or semver, and they will release new features in minor upgrades, whereas Postgres doesn't. And I think that's really important. I think not only will they only release new features in major versions, it also means a major version does not necessarily mean breaking changes, whereas in some other platforms a major version will bring breaking changes. Naturally, it's also the only place Postgres will introduce breaking changes, but it doesn't mean there are, and they're quite often, I think they're quite rare actually. I think Postgres is really good at maintaining backwards compatibility. So I think sometimes people think of, maybe they're a bit too scared of major versions in Postgres, whereas obviously you need to test, but if you read the release notes, there aren't many things that your existing system will stop being able to do.
Right. Well, yes. So speaking of differences between minor and major versions, it's still worth remembering that Postgres changed versioning schema from 3 numbers to 2 numbers roughly 5 years ago. Right, when Postgres 10 was released after Postgres 9.6. And this caused 2 issues. Some people started to think that there is such version as 9, just major version 9, never existed. But some people, vice versa, they started to think that it's if you check, no, there is no different problem, sorry, right? Or there was, I don't remember.
So yeah, I didn't see anybody confusing, for example, 10.0 and 10.1 and thinking those were 2 different
I also
major versions. Mm-hmm. But I do see people referring back to like 9.5 and 9.6 as if they're the same version. But those, so that's the time it changed, right? After the 9.6 was the last point release. So I'm calling that a point release. That was a major version, and then we went to 10.0 and then we went to 11.0 being like the next major one after that. So these even back when it was 9 point something, these were major versions that were released annually. And yeah, it's nice that now looking back, we've got 5. The oldest supported version is no longer confusing. So it must be more than 5 years ago, which is cool.
But we still have some production systems with older version, unfortunately, unsupported and not upgraded yet, which lag in terms of upgrades a lot. I wanted to, returning to this question, when to upgrade, there are 2 different, also different directions. First, we all want to be up to date and benefit from all fixes including security fixes, and also from new features, including performance-related features. And at the same time, my nature is more development nature, and like although I advise a lot of ops people and companies in terms of administration of Postgres, I always tell people that my nature is development. I always try to move forward with new features, new exciting stuff, and so on. But of course, over time, since I have many years of experience, I developed some practices to avoid moving too fast and too early, to untested, and so on. But at the same time, there is a big idea. Let's not use the latest version because it's probably not ready for our very serious production case. And this is reasonable. So there is, for example, when new major version is released, some people say, okay, I will wait until a couple of bug fix releases, right? Like, okay, now 15.0 released. I will install 15.2 only, right? I will wait. And this is reasonable because bug fixes happen with a new major version released. A lot of new testing is happening in reality, in production testing, right? And you can benefit from it if you wait. But if everyone is thinking in this direction, imagine that it will not be tested well enough. So it's
I also think in practice it hasn't worked out well like that. If you look back, it's at least since I've been following Postgres, there haven't been major issues in the 0.0 releases, except for one occasion. So in the last 7-8 years, there haven't been any huge issues in .0 that weren't in .1, except for 14.0, which had which was only fixed.
14.4, yes. But
exactly.
A lot of
that's the only example.
A lot of corruption cases happened as well, and so on. No?
In which other versions?
Well, in all versions, something happens. For example, create and recreate index concurrently.
This is the example. This is the example I'm talking about from 14, right?
Right, but there were several problems with create index concurrently and index concurrently. Not only in 14. Before also issues happened in 13. Where it appeared in 12, I don't remember. In 11 maybe, right? Several, like almost every year something happened with this unfortunate but very important functionality, which doesn't follow ACID principles because it can leave you with some leftovers, and this is not transactional, of course. But under load, this is what you need, create index concurrently or index concurrently. So this is only one example. There were issues in Gist, some issues in Gin indexes, there were issues. Like every release has some issues, major release, always.
Of course, right? But otherwise we wouldn't need bug fixes. But all I meant was that the biggest issue I've seen in the last 6-7 years wasn't fixed until .4. So anybody who waited until .1 or .2 didn't benefit from that strategy in that case anyway.
That makes sense. But this example shows the downside of these tactics. Let's wait a couple of bug fix releases. I agree with you. And also, well, security bug fixes happen at any time. It can happen with .10, .15, anytime.
So until it's out of support, and that's the other thing driving upgrades, right? If you want security fixes, you need to be on a supported version of Postgres. And that's quite important because eventually, there's a nice window. 5 years is a nice window in terms of length, but it's also not that long. For large enterprises, by the time you've tested an upgrade, maybe that's taken you 6 months to a year. You've already lost one of those 5 years. And then you need to start testing the new one before that one gets out of support. So even large companies are probably having to look at this at minimum on a 3 to 4 year horizon. So it's even if you're not doing it every year, even if you're waiting, so it's not the latest version, and then you want to make sure you're on a supported version, your window isn't that long, but it's long enough. I think it's a very good policy.
Yep. So long story short, we want to have if we are good Postgres ecosystem citizens, we should start using new major version earlier as soon as possible on maybe smaller databases or less critical databases first to help testing and so on in production. I mean, here testing, I mean using in production and deliver feedback and so on. And if bugs happen, okay, you participated and found something. But I understand those who wait a little bit also. I understand them.
Yeah, I think also if you've got a system that would particularly benefit from a new feature, like if you've got, let's say, it might not be one of your more critical ones, but there might be another reason that you can take that risk with a different database, right? If the benefits of the new feature might outweigh some of that risk. So I've definitely seen some people skip some major versions if there's not any major features in there that would make a big difference for them, but then go quite quickly onto the next major version because there is a feature that's particularly interesting that would help them a lot with some other problem. So I've seen that strategy a little bit as well, kind of picking and choosing.
Or since like upgrade might require a lot of efforts from many people, sometimes the companies have major upgrades only once per 2 years just to save on overhead because it's painful. Still a lot of pain there. But minor upgrades, let's talk about minor upgrades.
Yeah.
Do you think it's worth upgrading always to the very fresh version in terms of minor upgrade? For example, if I'm on 13, I want which version?
I can't keep track. It's probably the number of quarters since
it's printed on the main page always. Well, not always, but latest releases and so on. So now it's 13.10. Right, so it's
nice. So about 2.5 years since it came.
11th upgrade, 11th minor version in this major branch.
So a good question. I'd say most of the time, yes. I don't see much downside to upgrading minor versions. I guess we're going to talk quite soon about some of the difficulties of major version upgrades, but we don't have those with minor versions. A lot of the cloud providers make it extremely easy to
But they lag, always lag.
Because they do, sorry, but for minor versions, they're quite good.
No.
Oh, okay.
I mean, depends, but sometimes it's several weeks. And if it's security bug,
sure,
it's not good.
Yeah, agreed. So yeah, what do you think? Do you think that you should always be on the latest minor version?
Yes, I think yes, but you still need to test it. Some automated testing some workflow should be developed, like tested first on lower environments for a couple of days and then release. And also extensions, they have some of their own life cycle, except those which are contrib modules inside Postgres distribution, Postgres contrib. So they also require testing, and I had bad incidents causing segfaults when some extension was released not properly tested, and it happened to reach some critical production system, not released, not tested in both cases by developers who decided to release it, and by SREs who just forgot to put it to some stop list for upgrades to proper test, and they had an automatic upgrade of the extension using it was CentOS or Ubuntu, I don't remember, but it was some automatic upgrade of packages without proper testing. So 2 mistakes, and we have bad consequence. Some testing is needed, but in general, you should be on the latest version in terms of minor upgrades. And there is a perfect resource to check the diff in terms of functionality. Why upgrade depeche.com? Why upgrade with dash .depeche.com? Always recommended.
Yeah, it's fantastic. It's really good for major versions too. I like that they give kind of big red warnings for security issues. It's quite a nice resource. If anybody's ever interested in being able to search like text-wise as to whether like there have been any changes to a certain feature or any commits with mentioning a certain feature in the last couple of major versions, or if you want to see what's in specific minor versions, it's a really good resource. Should we talk through the options people have for major version upgrades?
Let me confuse you here. I just wanted to point out, I saw on why upgrade there is also diff in options for major versions. Which options were removed, which were added in terms of
Yes, so like configuration.
Yes. So it has it all as well, also useful, because not only entries in release notes, but also configuration options, diff, which probably returns us also to another resource I mention quite often, PostgreSQL code.nf, to deal with details about configuration options for different versions, major versions.
Yeah.
So, right.
There's one other resource that I've forgotten the name of, but Ryan Lambert from Rustproof Labs released it, and it will show you not just the config, like it will show you any defaults that have changed as well. I'm not sure if the Depes one does that. So like if it's an existing configuration option, but the default has changed.
Default is very, very, very fragile topic, because there is default defined in Postgres source code, and there is also default which sometimes is different. For example, for shared buffers, which is defined by official PostgreSQL package apt or RPM package. And which default are you talking about?
I think he builds from source, so I suspect it's that one.
That one you probably see when you select from PG settings. There is a reset value or something there, and this is default came from sources. But usually people don't have different defaults slightly. So if you check how PostgreSQL, for example, apt package is created, is made, then you will see that it overrides some defaults. So it's interesting topic. Yeah.
I think what these sites are good for is kind of giving you like reminders of things to check. Like you should still do your own checks, right? It's not that you should treat these as gospel. It's more that they remind that some of these settings might have changed as well. What's that like in your system? Does your cloud provider change it to something different? Like does your cloud it gives you an idea. I understand.
Yeah.
But I think I find them a good reminder of things that I should be checking. Are there things that I would have forgotten to without looking at some of these tools?
Right. Well, yes. So regarding minor upgrades, how do we do it? I prefer doing it with minimal downtime.
Mm-hmm.
It's possible to do it almost without downtime if you have some proxy connection puller in the middle supporting pause resume approach like pgbouncer does. It's possible. Others also try to implement it, I see. But it's slightly different topic. My main advice here is don't forget to issue explicit checkpoint, because if you just restart, you need to restart Postgres. Your minor upgrade is just replacement of binaries, basically. New binaries, you need to stop using old ones and start using new ones. So it's a restart. But a restart, if done just straightforwardly, like not thinking about what's happening, under heavy load, with higher max wall size, if someone tuned checkpoint properly, restart might take time, significant time, because Postgres, when shutdown attempt occurs, Postgres first executes shutdown checkpoint to flush all dirty buffers to the disk. So to save all pages which are not safe from memory to disk, obviously, right? But while Postgres is doing this, no new queries are accepted. So clients start observing errors. And if it takes a minute, in heavy loaded clusters, it might take a minute. It's not good. So instead of just allowing Postgres implicitly do everything, you issue explicit checkpoint right before you restart. In this case, shutdown checkpoint will not have work to do, right? So you already say, well, a little bit, because how much of buffers happen to became dirty again? Dirty means like changed in memory, and just a few. Right, if you do explicit checkpoint, just SQL checkpoint under super user, and then immediately restart. Immediately after it, well, not immediately, of course, everything has duration, right? You restart, only few buffers are now dirty, and shutdown checkpoint have just a little work to do, and restart becomes fast. I see problem here that Postgres doesn't tell somehow, like it could tell. There is opportunity here, but it's for improvements of Postgres. There is opportunity to suggest what Postgres is doing right now in terms of this shutdown checkpoint. For example, every 1 second it could report to logs or to output shutdown checkpoint, like progress bar or something, like 20% done or something, right? Because some people, I've observed it many times, some people issue restart or stop for Postgres service, and after 10-15 seconds they become very nervous, not understanding that it's still doing some work, and they start doing very crazy bad things. For example, kill -9, issuing sick kill, and so on. And then this is like not good at all. You already have a crash basically and need to recover. And then during recover also they have similar issue, not understanding and what is Postgres doing right now. If you check PS, what I do usually, I check PS during recovery time. If it happens that we have recovery, and in PS in detailed in top, for example, top, you run top and then press C, you see common details. And there you will see details for Postgres, even if it's still starting up and doesn't allow connections. You will see LSN and it's progressing. This is the most important. I just discussed it earlier today on different topic. The most important progress bar UX feature is to let you know that something is happening for good, right? So some good work is being done right now.
Yeah.
Unless if you don't have it, you can start be very nervous and do mistakes. So this is what we have. I have to in my mind. Speaking of restarts and for minor upgrade, we just need to care about restart. Well, some other features like what about extensions as well? Do you want to upgrade them at the same time? If they of course you need to check release notes. That's why we mentioned why upgrade, because the release notes might tell you that, for example, you need to reindex some indexes.
Yes. We're not talking about. I guess actually, yeah. I was thinking
14.4
it shouldn't be true for minor versions. Yeah, I was thinking it shouldn't be true for minor
14.4.
versions, but exactly right. Yeah. Really good point.
Fortunately, if you check what happened carefully, for example, for 14.4, it told that some indexes might be corrupted. Well, we have some tools to check which indexes are corrupted, at least for B3. There is official tool amcheck. It doesn't work for GIN and GIST indexes yet. There is work in progress, still not merged to the source, to the repository, not committed. But for B3, we have quite powerful tools. So if you don't want to reindex everything, also you can plan to reindex everything just for your safety, to get rid of loads and so on. But if you don't want to do it during downtime, because for 14.4 we require downtime, unfortunately.
Yeah.
Or unless you involve logical replication, we talked about it. We will talk about it in a minute. So you need to find exactly which indexes are already corrupted and reindex them.
Well, yeah, I think you're right. I think that would give you quite a high degree of
Detail.
safety, but equally, Amcheck will tell you that an index is definitely corrupted, but it can't tell you for sure that an index is not corrupted. So I would still be nervous. Especially around 14.4, I would have still re-indexed everything personally.
I think you are not right. I remember problems that early versions of GIST and GIN support in Amcheck, which is still in progress, they had false positives telling that some index is... there are different types of corruption, first of all.
Yeah,
right?
okay.
And when we check heavily, and this check requires some exclusive, not exclusive, but some heavy logs blocking at least either DDL or writes. I don't remember exactly. So you cannot do it on the primary, just online. You need to do it on some copy of your database. So if the tool says nothing, it's indeed nothing in terms of what it checked. So no false negatives.
Okay, this confuses me. I thought it was the other way around. I think I might have even made this mistake before. I'm getting deja vu.
I might be mistaken as well. Worth double checking. But in real life, we could not afford the indexing everything like during downtime or immediately after. I think for this case, when you do minor upgrade, if we know already that we have already corruption, we found it, we can do it online after minor upgrade, and probably think about consequences of this kind of corruption. It depends on the application, what exactly happened and so on. But of course, worth checking how AppCheck is working. It's like it requires additional expertise to. I don't remember everything. I'm checking myself all the time as well. I can share only my mistake. I did it twice. I thought AppCheck cannot work in parallel. Of course, if you want to check, it's like with indexing as well. Sometimes you need to move faster, like parallelization of analyze and some processes useful during upgrades. So AppCheck can be executed with -J option if it's CLI tool, pg-AppCheck. And I keep forgetting about it, and I have several versions of my own implementation for parallelization of AppCheck. So don't be like me, just use the existing tool. It supports it. So yeah.
While we're in this area of like talking about corruption, I feel like it might be sensible to discuss glibc versioning and
but it's
OS.
more about major upgrades. Sometimes people try to combine several big changes in once, because it's stress. Sometimes you need some downtime. Most often you need downtime to plan downtime. When you run PG upgrade, even if -K or -link, so hard links involved, should be fast, like a minute or two, but still it's a minute or two. You need to plan it, or then also you need to analyze, probably in stages, depending on application. If your application works well when default statistics target is low, so rough statistics, still it's either downtime or no, like depends. But overhead significant, and sometimes management might decide to combine multiple steps in one. And if you change, for example, operational system version, switching from old Ubuntu, for example, 16.04 is already out of picture in terms of support. We need to change. Every glibc version change should be checked very carefully in terms of possible corruption. So again, like AppCheck is very important there. But in general, if you can afford not doing multiple big steps in one step, not merging them, I would do separate upgrades for operational system, separate upgrade for Postgres major version, probably hardware. Hardware is easier usually, and so on. Just because it reduces the risks of being in a situation when you don't understand what caused some issue. Like you upgraded, you see something goes wrong, and you have wider field to analyze what is like the possible reasons of it, right? So root cause
also,
analysis
they multiply. Like it could be one, it could be the other, it could be both.
Dependencies.
So you have so many, exactly, yeah.
So root cause analysis in case of issues after upgrade might be very expensive and problematic. So if you can afford doing separate steps, you should afford doing separate steps. This is my usual advice. But of course, real life sometimes tell us let's combine steps. In this case, just proper testing and so on. Right.
I kind of forced us onto major versions of upgrades, I guess. Was there anything else you wanted to talk about on the minor version upgrade side?
Well, minor upgrades, that's it. My advice is checkpoint, and that's it. I don't know what else to mention there. So
I don't think so either. Only that the security patches come out. Like I think they come out every quarter unless there's a really big security issue.
Yeah, there is schedule. If you Google Postgres version policy or something, there is a wiki page describing the schedule.
I'll make sure to share that. And that they get backpatched to old versions for about 5 years, a little bit longer, I think, but not much.
And those releases usually happen on Thursdays.
Nice.
So just
I didn't know that.
it's like it's my favorite game is released on Thursdays as well. It's in virtual reality, and I think just people want to have Friday for to react to issues, not weekend, right? So it
Interesting.
makes sense, right?
Fair enough.
Mhm.
Cool. All right. So major versions. We've mentioned a couple of things already. PG upgrade briefly. We talked about logical. Do you have like favorites in different scenarios? How do you tend to approach things?
It's I would like to like let's be brief because we already approaching our limit in terms of time,
True.
and this is of course a huge topic.
Oh,
And what?
I have a recommendation. Was it you did a panel discussion? Was it
Twice.
recorded? Yeah, was one of.
No.
That was good. I think there might be. Anyway, I'll look for that if there's a recording of that. It was
No,
great.
it was not recorded.
Okay.
So,
Damn.
yes, but there is some article with some summary. We can attach it. So, if you want to upgrade with, like, right now, the standard de facto is using PG upgrade in place,
Yep.
upgrade. It involves dumping schema, creation of new cluster. Cluster means like the PG data directory, and then dumping, restoring schema, and then dash K speeds things very well, hard links, and then you already can open gates and analyze in stages. First, query execution plans will be not good because statistics is not yet collected. But analyzing stages starts from very rough statistics, low number of buckets, and then jumps, and then finally you have proper. I would like to recommend looking at all nuances here, how Alexander Kukushkin implemented this in Spilo, part of PostgreSQL operator for Kubernetes from Zalando. Alexander also is maintainer of Patroni. So Alexander implemented it very well in Python, checking also things about extensions and so on. And already, I suppose it already very well battle tested at Zalando, where they have a lot of clusters.
Yeah.
So they already, I think, upgraded. I'm not 100% sure, but I'm almost sure they upgraded a lot of clusters. We can check with Alexander on Twitter. He's active on Twitter sometimes, so you can ask him there. So Alexander, by the way, just a side note, he's not at Zalando anymore. He's working at Microsoft. Patroni recently started to support Citus. It's interesting. But anyway, this is, in my opinion, very good implementation of automation around PG upgrade. Because Postgres lacks a lot of things to automate these things. You need to automate many steps. It's not like a button and that's it. Right? So, unfortunately, this is a problem. But then there is also approach involving logical replication to minimize downtime almost to zero. Not really zero because you need to switch over, to implement switchover, to execute switchover. And during switchover, some of your users will see some errors. So it's not zero downtime. It's like it's so-called near zero downtime.
Yeah.
And by the way, if before switchover, you also don't forget about checkpoints, on older versions which require restarts during checkpoint. And Patroni restarted all nodes during switchover. This is important. In this case, they happen faster. Newer versions, promotion is implemented better in a better way. So, speaking of logical, usual approach is, if you have not big databases, is to initiate logical replication to new cluster. Basically, data will be brought there at logical level. Think about it like dump restore. Eliminating bloat, good side effect, right? But this also happens involving quite long transaction on the source. And sometimes this process cannot converge if you have dozens of terabytes under heavy load. It's very hard to use it. But for smaller clusters, you have logical replication. It's working. And then you just switch over there. Good thing here that you can do many additional steps while logical is working. You can reindex some indexes, fixing any issues. You can adjust some things compatible. Of course, logical has a huge list of limitations. Still, they are being improved. In 15, Postgres 15, a lot of improvements. In 16, there will be more improvements. For example, in general, you should think about sequences. Sequences need to be synchronized. Otherwise, after switchover, you will have overlapping usage of old values. So, and basically insert won't work if you have some sequences in some old tables and so on. So you need to reset value to match all new value plus maybe some gap. If you use integer 8 big int primary keys, you can afford making gaps like millions. Nobody will notice such big gaps because our capacity is huge.
Yeah.
And then you also need to think about blocking DDL during this procedure for existing versions because DDL is not logically replicated, and several more restrictions worth checking. But again, for larger clusters, this recipe doesn't work because we simply cannot initialize such using this logical level. There is a trick. We can use physical standby converted to logical using recovery target LSN. Now we have logical replication, and we can upgrade it initially, and then switch over. Right? Thought I a month ago, and I was mistaken because during running PG upgrade, logical replication is becoming inactive, and we have some data loss there. So new recipe. Yeah. But there is new. By the way, there is a good discussion in PGSQL Hackers. There is some hope that future versions of Postgres will allow you to use logical and PG upgrade together officially. What I'm talking here is some recipes from not a good life. We try to invent something for heavily loaded big systems, and there is such recipe. We instead of using a logical, converting physical to logical and then running PG upgrade, we just create a slot, allow physical to reach recovery target LSN, matching the slot position in terms of LSN. Then we don't switch to using logical replication. We keep accumulating some lag on the slot, on the primary, old primary. And then we already run PG upgrade. It's very quick, right? We don't analyze. We analyze later. And then already we switch to using logical, cluster already upgraded. So we just starting to use logical. We don't have any data loss in this recipe at all. And then we can analyze. We have quite good time to run analyze even without stages. We can analyze it for our recovery target. Yes. During this, we keep using logical. The only requirement here is to know 100% that logical will keep up. I mean, it will not lag. And here I also it depends on workload. In some cases, wall sender is our bottleneck because it's single. You cannot parallelize this work. Right. If you have multiple wall senders, all of them they still need to parse whole wall stream. So if you had 100% CPU on one wall sender, you will have multiple wall senders using 100% of multiple cores. Not good. But on the recipient side, we can use the trick parallelizing work among multiple slots and have multiple workers, wall receivers, and so on. And in this case, we just part of our tables are processed by one logical replication stream, another part by others, and so on. In this case, we can move faster, keep lag lower, and have again zero downtime upgrade for large clusters. Final trick: there is PG bouncer here. If you can afford pause resume, depending on workload, you may have real zero downtime upgrade, right? But I never saw this recipe described anywhere. We just some secret with testings right now. Maybe we will publish some article in some future.
Definitely should. I see this come up from time to time, but honestly, most of the time, people I talk to don't have zero downtime as a really hard requirement. If you can afford a few seconds or here or there, or a little window once every year or every couple of years for this, the options become much, much simpler. So I tend to see people go that route. So But yeah, for huge systems under load, I can see how that's awesome.
Right, and I agree, but sometimes we have a problem that, for example, if we have a small downtime, it can cause requirements for additional downtime, like window starts to grow because, like if we need to stop it for 1 minute, we need to stop some other components, and when you already have 10 minutes requirement, and then it grows to half an hour and so on, it's not good. But I agree, in many cases we can afford some brief downtime. In this case, a recommendation is to take care of your application code and make sure that data loss doesn't happen in case of when database is down. And all systems should be resilient to brief outages. So
or
retries,
even have like
retries.
a read-only. Or yeah, retries are great. Or have a read-only mode where
Read-only
where
mode
you have-
plus retries for writes.
Yep.
This is the best approach, and it should be used by all backend developers, in my opinion. But the problem is usually people they understand it, but postpone. Like it's like with CI/CD coverage testing. We have good testing, but always room to improve, and so on. But in reality, you need to design your system for not to lose writes, read-only mode, and test it regularly. For example, switchover. Okay, some writes failed, but users either didn't notice or they were told explicitly that the form was not safe or some data was not safe. Please retry explicitly. Press the button one more time. The worst implementations, we told the user we saved it, but database lost it. It's bad. This is what can happen here.
Yeah, not good. Cool. All right. Anything else you wanted to make sure we covered?
Well, we didn't cover a lot of small topics in the PG upgrade area. It's a big topic. How to benchmark properly, how to test it properly. It's a big topic indeed. But I think it's good enough for this short episode.
I think so. We can we'll link out to various of the things we mentioned. A couple of good resources on this, but hopefully given some people some good things to look into.
Yeah. And I hope future versions of Postgres will have better page upgrade workflow, more automation around it, and so on. But unfortunately, for example, this PostResume, which is implemented in PG Bouncer, I don't have hope here because all attempts to bring Pooler inside Postgres failed, unfortunately. So Pooler is considered as external thing, and I don't we cannot achieve real absolutely zero downtime using just Postgres core. We need additional pieces, so it makes things
I wouldn't
more...
be shocked. Yeah, I wouldn't be shocked to see this solved at the operator level or even the cloud provider level. Lots of cloud providers maybe they'll work together one day.
Operators.
Yeah, exactly.
I think they do already this thing.
I hope so.
I'm lagging. A lot of interesting things happen in development of Postgres operators for Kubernetes, or Kubernetes operators for Postgres. What's the right choice here? They automate more and more and more. Like, for example, I know Stagress has a lot of automation, including this. Maybe not fully, but some parts of it, and they have like reindexing, index maintenance automation. We had an episode about it, and so on. So, yeah, I think this is good area to expect improvements from the developers of operators.
Nice one. Well, thanks again, Nikolai. Thanks everyone for listening, and catch you next week.
Okay, bye-bye.